everyone, thank you for coming. I'm pretty excited to do this, but we're here to talk about insulating concrete forms, and I'm going to really cover the building process, not in detail of how to stack the forms, but the other things that go along with it. Products you might look at using along with building insulating concrete forms that help make that part easier, some of the things we have to do differently, and how that's done. I have some samples as well that I'll pass around. They're in my dusty barn, so they're not entirely clean. So if you're wearing white clothes, maybe don't grab those. What we're going to cover is basically what is an ICF, then we'll move into some of the differences between brands. I have several of those here. Why people choose to build with ICF, products to use with ICF, engineering, planning, some installation details, how we finish it, and then a little bit about what it's like to live in it. And then we'll have time for questions and answers. So what is an ICF? When you talk to people about building a concrete home, this is what they have in mind: a square box with no windows. It does not need to be that way. An insulating concrete form home can look just like any home. You can use any type of finish on the outside that you want. You're not going to see concrete. ICF stands for Insulating Concrete Forms, or sometimes Insulated Concrete Form. So it's a way of building a concrete wall that is insulated in one step. The insulation is the form. We pour concrete inside it, and the form stays in place, providing insulation, and there's furring as well incorporated into it. So this block is cut away a little bit, and you can see there's a plastic stud here which we nail or screw objects into. So after the wall is poured, it's ready for finishes. On the outside, the siding is nailed in. On the inside, the drywall is screwed on. So in one step, it's a weatherproof home. This picture shows how the rebar is incorporated in. It's clipped into these spots. Depending on what the engineer specifies will be the size and the spacing of it. And then the concrete is vibrated into place to ensure that there's no air pockets. Back in the day, when insulating concrete forms first came out, there were a lot of problems with blowouts. That means the form broke and concrete spilled all over. The forms have improved immensely. Even in the 15 years I've been in business, they've improved immensely. And now, instead of pouring in a 2-foot lift at a rate of about 1 yard per 10 minutes, now we can dump 10 yards off in 20 minutes, and we can pour 4 feet high at a time or more if we're really daring. So I'm going to pass one of these around so you can get a good look at it. Just keep it going. And then as well, I'll pass out a stud from the inside of it, and this stud has different nails or screws fastened into it, so you can see how that goes. But nail guns work perfectly fine, as well as screws. Some of the differences between the blocks. So the one that's getting passed around right now has a folding tie that you'll see. It allows it to fold flat. This one it's not folded, so it takes up more space shipping, so you pay a little bit more shipping for this kind. I'll not pass around the big one. This is a commercial grade that actually uses steel instead of plastic for the ties. They're a much larger form and then can handle a lot more pressure. But basic differences between ICF walls. When they first came out, there were a lot of walls that were post and beam style. The forms were solid foam. They did not have plastic ties. And the two sides of foam were connected then by foam itself, and it created a grid of concrete posts and concrete beams. These were really hard to fill, and you had to fur the wall out afterward in order to attach any finishes. After that came waffle grid. That's the second one here, where you still had posts and beams, but the concrete was continuous. It just went to about 2 inches thick in the middle. These were also difficult to use to ensure that the concrete was continuous without voids. All of the block that we use and all the major players now are what's called a flat wall. Just a plain old flat concrete wall is what ends up being formed. So the engineering is very straightforward. All engineers are familiar with flat concrete walls. Good luck finding any of the old ones, and if you do, stay far away from them. They've got a great sales pitch, but in execution, it doesn't turn out all that well. Ask me how I know. So the forms are built out of EPS, which stands for expanded polystyrene. It does not use the harmful blowing or expanding agents that like the pink foam does, which is XPS. So this type of foam does not off-gas at all, and it's 100% recyclable. Some other differences between brands of ICFs are whether they are assembled on the site, whether they are folding. So let's start first with pre-assembled. The white one that I've passed around is a pre-assembled block. So is the other piece, but that one again folds flat, so I can ship a lot more in one truckload. This one also can fold quite a bit flat. So those are three big differences. Yes, sir?
Jeff, how much of a concern is the ability to ship all of this compact?
Good question. Yeah. It used to be a lot more of a concern when there were only one or two places in the country to ship from. There are now so many all over, that's less of a concern. But on a larger home, if I chose a folding one, I might have one truckload. If I chose a non-folding one, I might have two truckloads, so that's an extra $1,000.
Okay.
So it is a consideration. Yes?
The last one you passed, how many inches is that?
Okay, thank you for asking. So that was the white form. That's an 8-inch core. The first one I passed through is a 4-inch core. They're all available in 2-inch increments. So 4, 6, 8, 10, 12.
Now, is this the 8-inch? Is that standard for residential, or is it's choice? I believe most of them are 6-inch. 8-inch is if somebody just wants a beefier house.
No, 8-inch will be required in certain cases by the engineer. So taller walls are the main thing without intermediate support. Another difference between brands is how tall the stud is. So in the case of this one, the stud is full height. We can just see it right here. So the stud sits on the stud. There's an advantage to that is that there's not going to be any settling during the pour. The disadvantage to that is when I go to put electrical in, I have to cut through the stud as well. Very minor disadvantage. So we like products with a full height stud. The next thing would be R value. Everyone always asks, I named the company R value, what is the R value of your wall? Well, the standard forms, all three that I have here are R23, but they are available with extra insulation if we desire to do that, and I'll get into whether or not that's a good idea in a little bit. The last thing, once they're installed, it really doesn't much matter which brand you have. The choice on which block you're going to use is mostly going to come down to what's most available, what the installer is most familiar using, what you've got great support for. So for most of these, they're not stocked locally, and so you'll order extra in order to not have to wait 2 weeks for more. Well, if it's stocked locally, there's quite an advantage in that. You can return extras. If you run short on something, you can just buzz over and get it. So those are the kinds of things that are actually most important when it comes to choosing your block. Then there is the foam-free ICF. I'm not going to pass this one around. I'll just hold it up for you, and you're welcome to look at it later. This is called Nexsem. There's a couple of brands like that. It's made with wood fibers They call them cement bonded. I don't know exactly what they do to it, but I know that that's been sitting outside since 2015 and it hasn't decayed a bit. And I also know, because they said you could do it, we tried, you can hold a torch on it and it will not burn. The insulation that's used in it is rock wool, or also called mineral wool, which also doesn't burn, and neither of them biodegrade. Advantages, the main advantage would be it's foam free, and there are those who have environmental concerns with foam or health concerns. I can't see really any other advantages to it other than the fireproof nature of it. It is more costly to build with that. It takes more work to finish. We have done it before, so I do know what's involved. I'm happy to do it again, but there is that caveat.
Jeff, do these always have that void between the insulation?
It's filled with concrete.
Okay.
Yep, it's still an insulating concrete form. So it stacks, put rebar in as you go, and fill it up with concrete.
Is that opposed to like having furring studs?
Yeah, okay, good question, thanks.
Do that,
I should have mentioned that. You can attach anywhere into this block. So that's one slight advantage. Whereas these, they're probably isn't going to show up from where you guys are sitting, but once you get close, you can see the studs are marked there. And once again, they're about a ½ inch below the surface.
But running conduit through something like that, more difficult?
That's very difficult, yes. So you end up chipping a groove out and then putting the conduit in, yeah. A third difference between some brands of insulating concrete forms is vertical versus horizontal. So these blocks, I'm just showing you little samples. This one comes in a 4-foot long block. The green one comes in an 8-foot long piece. They're horizontal and you stack them very similar to a Lego block. But then there's vertical blocks that install similar to a normal concrete form. I have installed one and it's very different, very different. I don't really see the advantages in using that one. And then there's a third kind that I don't have here. It'd be somewhat similar to the next SEM block, except instead of wood in concrete, it's beads of foam in concrete. Again, I don't really understand the advantage to that. So why build with ICF? The first reason people tell me when I ask, why are you considering building with ICF, is usually the efficiency. But after somebody's lived in it, when you ask them what they enjoy most, it's how quiet it is. Can't really quantify quiet. You can quantify efficiency, so we'll talk about that a bit. So efficiency and comfort are related, but they're not the same. You can have a very efficient home if you only heat it to 30 degrees, but that's not very comfortable. So we want efficiency and comfort to go together. And comfort comes from something called mean radiant temperature. And what that means is the average temperature of the surfaces in the room that you're in. Most of us have probably had the experience of walking into a warehouse with brick walls and being cold. That's because the block is cool. The air temperature can be up to where you would expect, 72 degrees, but when the block is cool, your body radiates heat to that block. We have a similar experience in older homes with single pane windows. Your body radiates heat to the coldest surface in the room because heat doesn't rise, heat moves from hot to less hot, and it radiates. So the coldest surface in the room is going to determine your temperature. So we want to raise the temperatures of the surfaces in the room, and we want them all to be within a couple degrees so that we're not uncomfortable in one spot versus another. So yeah, absolutely, this does mean good windows, but this also means not having thermal bridging. Thermal bridging is, in a stud home, areas that aren't insulated, where the heat can move through the stud wall at the studs or at the headers, and it creates cold surfaces in the room. I'll show you some pictures of it in a little bit. So comfort is mostly about mean radiant temperature than it is about air temperature. So think again, the temperatures of the surfaces in the room. That's why radiant heat offers a very comfortable heat, because it gives you a nice warm surface in the room. Often I'll be asked what's the right amount of insulation. So there is a calculation for determining the R value, and it's how many BTUs can move through a wall per square foot of wall in a given amount of time. It's very easy to calculate. The standard blocks are 5 1/4 inches of foam. I just calculated the R value, or the efficiencies of those, at 5 inches, and it's 93% efficient. I can double that insulation and I gain only 3.5% of efficiency, so 96.5. And every time I double that, I gain less and I gain less and I gain less. The bottom line is, when we have a continuous wall of insulation that isn't interrupted by studs, the R23 is probably going to be the right amount of insulation for you. The law of diminishing returns kicks in once we start spending money beyond that to insulate.
Jeff, does it make any difference in terms of climate that you're living in versus if we were talking Alaska versus Carolinas versus the island?
So first of all, my name's Jake. That's okay. Secondly, absolutely it does. Yes. If we knew it was consistently going to be 30 below in the winters, we would definitely look at more insulation. Absolutely. So those are factors we take into account when designing a home. One is going to be your climate, since Michigan's all the same climate pretty much here. We don't look at that specifically. We're going to look at what your budget is, how large your home is, what type of heat we need, whether we're going for net zero or some other type of rating. But when it comes down to budget, our goal is to design it to a point where the better money spent is not on insulation, but on photovoltaics. So we'll spend as much on insulation to get us to that point where we've kind of reached the sweet spot where more money on insulation doesn't gain you as much as that same amount spent on photovoltaic panels. Okay, comfort again. Insulating concrete forms are often chosen for comfort or for efficiency. Since they have such a low heat loss or heat gain, that means that your AC or your heat is running very low. Right now I can hear it running in this room. In an ICF home, it needs to run at such a slow speed, you don't hear it and you don't feel it. And you might think that's a small thing, but it actually makes the home a lot more comfortable. And you'll notice it especially a year after you've moved in and you go visit a friend and theirs kicks on. You're like, what is that noise? It makes a difference. Convective looping. Convective looping is illustrated in this drawing. You can have an airtight wall, but if you have insulation that's cellulose or fiberglass, air can move within that. That's called a convective loop. It will circulate from the cool side to the warm side within the wall and cause more rapid heat gain. This is insulations, by the way, incidentally. They're tested at 1 degree temperature difference. There's no convective looping at a 1 degree temperature difference. If you test an insulation at 70 degrees on one side and 0 degrees on the other, you notice very quickly which ones are good, because all the loose ones, cellulose, fiberglass, even rock wool, their performance degrades as that temperature difference increases. EPS foam, the performance actually increases as the temperature difference increases. Thermal bridging, I mentioned. We don't have any thermal bridging. And then the last one being thermal mass. Thermal mass would be the weight of the concrete that's inside the form. It doesn't offer you any R value, but it offers you stability. That core is a constant temperature and it takes a lot of heat to change the temperature of that core. We worked with Grand Valley State Engineering Department in one of the homes that we built and embedded temperature sensors in the wall from the footings to the roof every 3 feet. Monitor those for a couple of seasons, and the results show that that core changes temperature so slowly it's days behind an outside temperature change. So that offers you a lot of stability. It offers you comfort. Here I'm showing some photos that I've taken. On the left, hopefully you can see the lines in the roof. That's a SIP roof, structural insulated panels. And where you see those lines, that's where there's a joist. The rest is insulation. On this is a hotel that has steel stud walls, and it has 2 inches of insulation on the outside of all those steel stud walls. But hopefully you can see it from there. You can see between each stud there's moisture on that wall because the studs are leaking so much heat, even through that insulation, that they're drying that moisture off. Between the studs there's more insulation that doesn't leak the heat. So thermal bridging has some pretty real effects on things. What do you think that the plywood life on that roof on the left is going to be? I'll bet it's going to rot out at every one of those joists much sooner than everything else. These are taken with an infrared camera. Probably some of you are familiar with these photos because they've made their rounds on the internet. On the left is an ICF home. On the right is a stick home. And in fact, on the picture on the right, you can just see the corner of the ICF home. But the brighter the color, the more heat is leaking. So there's virtually no heat escaping the ICF walls. It is definitely leaking at the windows. But on the right hand, you can see thermal bridging like crazy. You can see every single stud in that home. And then thermal mass, I mentioned, offers you a lot of stability. In our climate, the main benefit is that in the spring and in the fall, on those days when it starts out below the temperature you want it to be and it ends up higher than the temperature you want it to be, you don't need to use any sort of HVAC because that thermal mass evens those temperatures out. So you can turn your heat on much later than your friends and turn it off much sooner. There's a smaller advantage too in that on an instance where the temperature drops really low for just a couple of days, your HVAC system doesn't really need to work extra hard for those couple of days. On the left, hopefully it's large enough for you to see. This is from the, I believe it's the EPA, US EPA. It's just showing all the spots on a typical home where air leaks in and air leaks out. In an ICF wall, air doesn't leak in and out. We don't have a joint from the top of the foundation to the sill plate, from the sill plate to the rim joist, from the rim joist to the plywood, and so on. A stick home is full of spots where air can leak in and air can leak out. And then the photo on the right is one of a stick home that was spray foamed. And those are my fingers there. This is a 3.5-inch wall cavity showing the depth that didn't get spray foam. So spray foam is great when it's installed well, but it's often installed inconsistently, and that's a perfect instance of where that happens. Another reason that people will build insulating concrete form homes is for the health of those who live in it. The main way that works is controlled humidity levels. In a standard home, there's enough air leaking in the winter that it brings in dry outside air and it leaks out all your warm, moist air. So that's one major way that the home is more comfortable. It's always the right amount of humidity without needing a humidifier or a dehumidifier. I'm going to read a section from a Harvard study on humidity. They were looking at why some hospitals had better infection rates or worse infection rates than others. And their conclusion, the one factor most associated with infection was, drumroll, dry air. At low relative humidity, indoor air was strongly associated with higher infection rates. Quote, when we dry the air out, droplets and skin flakes carrying viruses and bacteria are launched into the air, traveling far and over long periods of time. The microbes that survive this launching tend to be the ones that cause healthcare-associated infections, says Taylor. Even worse, in addition to this increased exposure to infectious particles, the dry air also harms our natural immune barriers, which protect us from infections. Since that study was published, there is now more research and peer-reviewed literature observing a link between dry air and viral infections, such as the flu, cold, and measles, as well as many bacterial infections. And it goes on. Humidity levels control how often you get sick, believe it or not. Since moving into our home, our family has been remarkably healthy. Is it all the home? I guess it's hard to say. But there are definitely very strong links between proper humidity levels and health. Dry skin is reduced, itchiness is reduced, bloody noses are reduced, you don't have static electricity going on. Another way ICF Home offers health is that you can control the quality of the air. When we don't leak air into the home, we can control the air that comes into the home. We use the ventilators to bring out the right amount of fresh air in, and we filter that so we can control it very well. In the picture on the right, hopefully you can see the water droplets on that plastic barrier. That's the inside of a stud wall in a parade home that we went through. And I have a lot of pictures of that particular year. What happens when you have a cold wall is that the water, the moisture vapor that's in the air, has to condense somewhere. It's going to condense on the coldest surface, and it's going to cause rot. We don't have cold surfaces, therefore we don't have water condensation, therefore we don't have rot or mold. The photo on the left is insulation taken out of an older home, and you can see it's quite dirty. It's dirty because it's an air filter. The photo on the right is showing streaking inside a wall when the insulation is removed, and that once again is where condensation has occurred on the wall and it's begun to mold. Another reason people often choose ICFs is for disaster resistance. On the left is a boulder that rolled down a mountain and was stopped by an ICF home. Fortunately, we don't have to worry about that problem here, but one that has happened several times is a car has crashed into a home. In fact, it seems like it happens every year. There are several photos on the internet of cars that have been stopped by ICF homes. This being one of them.
Is that in Florida?
Yeah. Of course, everything bad happens in Florida, right? Craziest news stories out of there.
Jake, you have a car crashes into a home. How do you repair ICF?
Okay,
construction?
very good question. Typically, your concrete is not going to be damaged, or it's going to be damaged very little. So I'm going to assume that there's little concrete damage. In that case, this foam has to be removed, and we would tapcon new furring to the wall and new insulation in between it. It gets screwed to the concrete core at that point.
So basically you're saying all the damage would be on the outside of the concrete, which means you haven't got any structural in the concrete in terms of cracking or that, or anything on the inside, such as damage to electrical or...
Yeah, there definitely wouldn't be problem on the inside. If there were visible cracking, you would want to consult an engineer about that. But for most cases, it's simply external. Disaster resistance is another reason. On the left is an incident that happened to me. What you're seeing is an ICF wall, and the foam on the inside has mostly been melted away. This is an instance where we had a propane tank with a little round heater on the top, and we were heating a basement to keep the floor we just poured warm. Somehow, during the night, it tipped and leaned up against the wall. And when we got there in the morning, that's what we saw. It had melted, but it had not burned. On the right, it's a little grainy This is from Hurricane Katrina. And we can see slab foundations for all kinds of homes, but there's one home still standing. That was an ICF home under construction. The last hurricane that just hit, and I can't remember the name of it, there was a very similar story and photos. Only home standing is an ICF home. Durability is another reason that we promote insulating concrete forms. The photo on the left here is one taken on a job site that I was doing some flat work on. And they used an excellent weather-resistive barrier. It's a great one. But when you don't install it right, it doesn't do you any good. So you've got this dryer vent here, and there's rips in it. You've got an outlet here. The water will run down this and right in to that wall here and at the dryer vent. This is common detailing that most people do, and they're creating problems. Is there a way to work around that? Absolutely. Do people do it? Not very often. It takes a lot of attention to detail. Insulating concrete forms remove a lot of those problems. The product itself can't decompose, it can't rot, moisture doesn't harm it. And again, there's no dew point in the wall, summer or winter. Any stud wall we build here has a compromise. The dew point is going to be in the wall either in the winter or in the summer. So we choose to build them in such a way that the dew point is in the wall in the summer because that's the shortest season. But we're still inherently building problems into our walls. This next home is a visible illustration of some of that. We were called to replace the siding and add some insulation on a home. It wasn't very old, I think about 10 years old at the time. And as we got into it, taking the siding off, we started seeing problems. Again, a good weather-resistant barrier was used. Hvac has got a great reputation. It's a fantastic product. But we started noticing right away a lot of decay in the Hvac. And then as we got further into it, under the Hvac, there was sheathing rot. Again, this home was not very old. It was new enough that it was using Hvac. Homes before that didn't even use Hvac. And yet there were moisture problems. Stud walls aren't built to dry out. When they don't dry out, they trap the moisture in. When the moisture is trapped in, it will rot. And as I mentioned, the number one reason people do build with ICFs, the number one reason they like them after they moved in is how quiet they are. And you might say, I'm building out in the country, what does it matter? It matters. I'll talk about my experience with it later, but it especially matters if you're building in a flight path or by a highway near train tracks. There it will make a big difference. And finally, the life cycle cost. An ICF home will far outlast any other home. Yes, it will cost you more, but it will cost you a whole lot less than replacing the house. Might not be your problem, but let's build for the future. Let's build for the next generation. And I have one caveat, lest you think building an ICF home is going to give you everything your heart's ever desired. You can't just swap out the ICF walls and expect everything else to work great. Building an ICF home to perform well looks like thinking through all the details. Everything needs to be rethought, from the way we do our windows, to our HVAC, to our ceiling details. It all makes a difference. So ICFs are a step in the right direction, and they're a big step, but more needs to go into it than just that. Any questions before I move on? Steve?
What's the average time of recouping our ICF in a well-built?
Yeah. Good. So Steve asked, how much time is the payoff on an ICF home? And I wish there were a one-size-fits-all answer for that, but what your heating fuel is will impact that. The size of your home will impact that, and again, what we're comparing it to. So what I can tell you is on a home that we recently did, it was drawn for stick construction, and we priced it out with a well-built stick home, meaning we had insulation on the outside to keep that wall warm enough to prevent condensation most of the year. We were air sealing that wall. And then we also priced it out with insulating concrete forms. And the ICF home was 3.5% higher. So very, very slightly more. On that home, the cost to recoup is probably less than 5 years. On a poorly detailed home, it's going to cost you more than 3.5% more. If we're just building code built, it's going to cost you a lot more than 3.5% more. It might be 10% more. But your energy savings are going to be higher as well. But this is a calculation we can definitely help you do if you're interested. It's just not a one-size-fits-all answer. Yes?
If you're starting with an architect, do you have to, or is it best to try and find one that's familiar with ICF, if that's the way you want to go, so it's done that way to begin with? Or can you say, design the house and then we'll convert it?
Converting is difficult because you've just designed a home around a 6-inch wall and now you're going to go to an 11-inch wall.
Right.
You're going to lose space in key rooms. Converting is very difficult. So it is definitely best to design it with the right thickness walls from the start.
Okay.
Products that go into or go with insulating concrete form. I'm not going to pass this around because it's large again, but you're welcome to look at it afterwards. This is called pre-buck. We use this to form out our window or door openings. You'll notice the back side there's a couple of dovetail shaped grooves. That goes toward the concrete. And in fact, once the concrete's poured, that's what bonds it to the concrete. These can be ordered any width, so we're not limited to 2x10 or 2x12. They'll work for any width ICF. It's very stable dimensionally. It doesn't ever split like lumber does. Another one is called Helix. Helix is a little metal fiber that's mixed into the concrete. It can be used either to supplement the rebar or replace the rebar, depending on how much you dose it. I like to use it as a supplement whenever the budget allows. It is not required for building with insulating concrete forms, but when you use it, you know the reinforcement is always in the right spot. When we're doing steel rebar reinforcement, we're always making a compromise. We're putting it on the inside of the wall, the outside, or the center of the wall, but it's never the entire thickness of the wall. It can't be. Then you'd have a steel wall. So Helix micro rebar is a nice product. Extra insulation. There are a couple companies out there that build ICFs with thicker walls for extra insulation. There's another method of installing more insulation in before the pour. So there are ways we can get extra insulation if the project requires that.
Does that take away from the strength of the concrete?
In those cases, what we do, John, is make the wall thicker. So no. If the engineering calls for a 6-inch wall and we're going to add 4 inches of insulation, we'll order a 10-inch core wall, throw the 4 inches of insulation in, and still have 6 inches.
Why would you do that? Why would you use what would call for the additional insulation?
Passive house certification.
Okay.
Yeah, that's
So
really it.
basically if you're trying to go net zero and
Net zero, you don't even need to, no. Remember I said, as far as net zero goes, we want to spend as much on insulation until the point where it's cheaper to go PV. And that's generally at the standard R23 level.
okay.
This is how the floor system is attached. I was not able to get any samples of it here to pass around, but there's a metal bracket that's poured flush with the insulating concrete form. It ties back into the concrete, and then the joists are hung off that. People are often curious about how we do that. The next one is the waterproof membrane, which I'll pass around. It's called a dimpled membrane because it uses dimples to create an air gap between the waterproofing itself and the wall. What this does is it allows for the wall to dry outward and inward. Most waterproofing, like a spray-on waterproofing, is going to obviously seal the wall so that all the drying has to go toward the inside. And that concrete, once it's inside here and poured, it dries for a while. It takes it quite a while to dry out. We want to allow it to dry both ways whenever possible. So the dimpled membrane allows us to do that. It also has two waterproofings. It's got that air gap it creates, and it's got the plastic itself. And thirdly, it's difficult to puncture. When I spray a membrane on foam, since that membrane is up against something soft, during backfilling it's pretty easy for a sharp rock or a stick to puncture that. Yeah, John?
Is that just on the part underground?
Yeah, just waterproofing. Yep, nothing above that. Electrical. A couple different ways we can do that. One box has teeth. You cut your hole in the foam, shove it in, the teeth hold it in place. Another way of doing it is using a box with a flange that can screw into the stud. So electrical isn't very difficult, but it is different. And so it's nice to have an electrician that has done it before. Because if they haven't, they're going to charge you an arm and a leg the first time. Engineering is an important thing when it comes to insulating concrete form walls. There are two ways to do it. The code has what we call the prescriptive method, where you look up a chart. How tall is the wall? What's the wind pressure in that area, or backfill pressure? How thick is the wall? And it will tell you how much rebar to put in. But there are times we get in special cases that are outside the limits of the code book. Really tall walls are one of those, or short corner jogs are another, where we consult a structural engineer. But since it's concrete, they're all very familiar with it, and it's not very costly to have it engineered. But most cases are prescriptive method, look up a table, no problem. Planning. So this photo here is taken from a set of prints that we built last year, and it was drawn for 2x6 construction. So what I want to point out here, this is an exterior wall with a little jog. These are windows here. When we made the walls thicker for insulating concrete forms, this window couldn't be as close to that corner anymore because the wall got thicker, so the window had to get smaller. This window would be okay because the wall is thicker to the inside, but we also lost space in this tight laundry room. So it's best to plan ahead of time enough where your prints are drawn for the right thickness of wall. If you try to convert, you're probably looking at changing room sizes, and it might be something you don't want to do. So we want to avoid difficult situations when we're planning our home. Distance between openings. So if we have a series of 4 windows in a row and they've got 8 inches between them, we either want to make those all touching each other, or we want to make a little more space in between them to get enough concrete. Same thing with how close we put a window or a door to the corner. We have to have sufficient concrete there to make it strong. And the other thing would be a short jog like this is a 2-foot jog. We can do that. A 1-foot jog, that's pretty hard. So planning ahead of time, working with someone who has built insulating concrete forms or drawn insulating concrete forms can save you money in the long run. Planning, we also want to firm up our window sizes ahead of time, because once we've poured that opening, there's very little you can do to change that, or it's costly to change that. And the next thing is, keep it simple, stupid. Don't try to plan around how long the blocks are or how tall they are. It's really easy to cut them. We cut them with a handsaw. So design the home the size that you want it. We'll build it to that size. You're not going to save any money if you build it 2 inches taller or shorter to try to accommodate the height of the block. You'll spend more money on the drywaller ripping his drywall. Installing. We pour one floor level at a time. So we'll pour the basement, then we'll put in the subfloor, and then we'll pour the next level, main level walls, put in the subfloor, second level walls. We don't pour the whole thing in one shot. And you can see why, one of the reasons why here, we brace to the inside. And bracing to the inside on a home, if the walls were 30 foot tall, there just wouldn't be sufficient room for that. So we build one floor level at a time. The rebar is put into these ties as we go. As we're building up high enough, the bracing goes on, and the bracing incorporates scaffolding. That's what this is here. Put in our beam pockets, put in sleeves for the water, electrical, any ventilation. Those sleeves are put in as we go. Then we pour, remove the bracing, and install the subfloor. As we're installing it, we're notching in for the windows. So the photo on the left shows the notches cut in the front of the home. Windows are already in the back of the home. This one shows from the top looking down inside a wall. It shows how we form in a beam pocket. So we just put some foam in there, pour around it, and then after the pour, you cut that foam out as your beam pocket. Finishing the wall. So the transition area, let me skip ahead to that photo a minute. The transition area is the area under the siding, but going down to the grade. So this home has to be graded yet. But that's the transition area, that's what I'm talking about. The code calls for that to be at least 8 inches high. So at least 8 inches between grade and where siding starts. That's for two reasons. One is to prevent rot of your siding, and the other is so that you can see if you got a problem with termites crawling up your home. So we usually cover that with PVC board. You can buy sheets, 4x10 sheets of PVC, rip it and cover the wall. We use fiber cement. We've used a synthetic stucco as well. You've got a lot of options for the transition area, but that's something to think about because unlike a concrete foundation, it does need to be covered with something. Another thing to think about is termite control. Most areas in Michigan aren't known termite areas, so most of us don't have that concern, but there are problem areas. And as the common strategy where we don't have a known issue is just to not have any foam uncovered. So in this case, right below the foam here, we have a peel and stick waterproofing that covers the top edge of that stuff I passed around. So there's no exposed foam. In an area where we know that there are problems, there's a couple different options. There's a chemical that can be added to the foam, but that's a chemical, kills termites. You can cover that foam wall with a stainless steel mesh that the termites can't eat through. Or there's the option of a concrete strip. And then there's a fourth option that I'll show you here. That's a little metal piece that's put in between the block as they're stacked. So if a termite were to be able to penetrate here and start crawling up into the foam, it gets stopped. So which strategy we use depends on how much of a problem we know there is in the area. Any questions on that, John?
You choose to go the chemical just to be on the safe side. You don't think you have termites in that area. How much more expensive is it to have the foam with that chemical?
I don't exactly know because it's been a long time since I've even looked at that. So I couldn't tell you offhand. Sorry. Steve.
Termites actually bore into foam?
Yeah, termites and carpenter ants will eat foam in order to get to something that they want. So it's not a food source for them, but it does provide shelter. Yep, they can. They can. In fact, there's some areas I've heard of people leaving a sheet of foam on the ground and they come back to it a month or two later, pick it up, and the underside has been tunneled through.
It's common in boats too.
Boats? Nice. Again, moving on finishing, the subfloor put in. Here you can see how, once again, it's fastened to the inside of the wall. We don't form a concrete ledge and set it on the ledge. This system allows us to put it at any height in the wall. And then trusses are installed. Here is one method for fastening the trusses. A top plate is bolted to the top of our concrete wall, and then that bracket holds the trusses in place instead of the normal toe nailing that's used. Another method for attaching the trusses is seen here, where there's a steel strap embedded directly in the concrete and it wraps over the truss. It would take quite something to pull that truss off the wall.
Does that take the place of hurricane ties?
Yeah, hurricane ties are almost worthless. They're rated at 85 miles an hour, right? The one that I've passed around there is, I think, 120 miles an hour, and I don't know what that is, but it's higher yet.
What do you call that one?
Well, the name is Simpson HETA. So it's an embedded truss strap.
It's code for apocalypse.
Yeah, right? HETA, it's something embedded truss anchor. Then finishing siding, I mentioned you can nail it in. The manufacturers will all tell you you have to screw in to this. I heard of one instance of somebody installing siding and nailing it in the winter, and they had a problem with the tie shattering. I've never had that problem myself, but the manufacturers do tell you to screw it in. I don't know anybody that actually has.
So you don't have to pre-drill, it's just,
No,
okay.
nope. And they hold nails really well, as that one I passed around demonstrates. So any type of siding can be used. Stucco, if that's chosen, can be applied directly to it. Just some more siding pictures. Vinyl over here. We have LP over here. And once again, you see we've used a different material for that transition. That's a really thin fiber cement. Yeah, John?
If you want brick,
Brick works, right?
Yeah. There is a brick ledge form. I didn't bring a sample, but a brick ledge form has the bottom half comes out extra wide and leaves you a ledge to set the brick on. Then the electrical showed you a couple methods of putting the boxes in, but an electric chainsaw is one option for cutting a groove in the foam. Another option is a hot knife. Just make sure you come back and you fill that gap in with foam after it's been inspected. Because when it's really cold out and that gap is open, you can actually feel that it's cooler there. So foam that back in. Cabinets. This is one a lot of people don't think about. Since we have a plastic stud that's 8 inches on center, each stud does not hold as much weight as a wood stud. We're not going to rely on just a couple of screws into a plastic stud to hang a heavy cabinet that you might load with dishes. So what we'll do is we'll hang plywood onto this wall before the drywall is put up. It will be just under the size of the cabinet that's going on, and we'll load it with screws to these plastic studs. That way when the cabinets are hung, they can put just a few screws in to that plywood and it will hold. Base trim here, this was 2009 when I was pretty new to this yet, and we thought we had to do this. We put some plywood on the wall, set the drywall on that, and then the base trim nailed right into that plywood. But since then my trimmer said he doesn't need to do that. He simply nails a diagonal into the drywall, and that's sufficient. Here we're showing drywall return, where the drywall actually goes back into the window. 1 second, I'll get to your question. A drywall return is often used, but not always. Because our windowsills are so thick or so deep, you can't order a window with that kind of extension jam. So you're site building those if you're doing wood, which gets pretty costly. So drywall returns are often used. Yeah?
Do you use any adhesives to bond like a piece of plywood to the foam? Or
There are adhesives that you can. Yeah, in fact, there's spray foam that's an adhesive. And any latex-based, PL Premium.
or eat it?
Yeah,
Okay.
yep. So you can, but we don't. So that's how we often will do windows: a wood sill, drywall return sides. This picture on the right, I guess, just showing a more finished product for you.
If you don't use the drywall return, what other option do you?
Then you're getting nice looking wood and building a site built extension jam. Yep. The other thing that's different with an ICF home is the HVAC. So our homes are airtight or very close to it for all intents and purposes. They're not going to breathe naturally. In your stick wall homes, you're relying on the weather to get you your fresh air. On a windy day, you might have more fresh air than you need. Get a couple calm days in a row and you might have some stale air in that home. We used balanced ventilation. This is a ventilator that brings in fresh air at the same time as it exchanges or exhausts stale air. In the meantime, it's transferring heat between the two streams. And there are some types that will also transfer humidity if we calculate that that's necessary. But either way, we use balanced ventilation, always the proper amount of fresh air with very little energy penalty because we're transferring heat between the streams. So that's an extra cost when you're doing an insulating concrete form home that you wouldn't need on a code-built home. Yes?
How much of an, I'm gonna use the term upgrade is that? And is that all computerized?
Okay, yeah, good question. So the extra cost is going to vary between $1,500 and $4,500 depending on how fancy of one you get. And is it computerized? The ones we use do measure air quality in the home and decide how much to run based on that. But there are very simple versions you can get that you can set up to just say run 20% of the time or 30% of the time, whatever. So the controls for it are whatever you want to spend. Is that what you're asking?
Yes.
Okay.
And then my question is, if you wanted to, I want to say for building this out in the boonies, and you wanted to be off-grid, use solar and or wind, does that require a lot of energy to run?
Okay, good, very good question. The question is how much energy to run. The more efficient versions are going to run at about 25 watts, and the less efficient 80. So if you're looking for net zero, absolutely you want the more efficient ones. They're about what 2 LED bulbs are on at a time, or half what an incandescent light bulb is. So not very much.
Do you tend to need more than one unit depending on the size of the house?
Yeah, larger homes will either use larger units or multiple depending on, again, the layout of the home. How easily can we route the ducting? Our strategy is to exhaust the bathrooms and sometimes the kitchen, sometimes the laundry room, areas where odors can build up are where we exhaust. And then we don't use regular bath fans, which they just dump your heated and air outside and replace it with cold air. So that's our strategy. And then we bring the fresh air in either into one common spot that's going to allow it to circulate in the house or into the duct system, again, depending on your home's layout.
Do you use a standard vent for the laundry room, though? Exhaust vent? For
No.
the laundry?
You're thinking of the dryer. Yes, you have to because of how much lint goes out and moisture. Yep. Yeah, and incidentally, on that note, an ICF home will leak enough air to run a dryer, but not a dryer and a wood stove. we cannot get our wood stove to run at all worth a toot when the dryer is on. You got to crack a window open. Yeah. Another different thing, and this may not be different depending on what your budget is to start out with, but we want to use a modulating furnace or heat pump. This means it doesn't have on and off. When it's on, it can be scaled down to 15%, or it can scale all the way up to 100%. It will actually measure what your home needs, and it will try to run 24 hours a day. A modulating is similar to driving on cruise control down the highway versus flooring it or coasting. A standard HVAC system is either flooring it or coasting. Not very efficient. Modulating tries to even it all out, run long and run very, very slow. In my own home, it's a heat pump, so we're not burning any gas. And at 30 degrees out, we're using about 1,500 watts, which is what a hairdryer uses. Yeah, John?
That's an oddball question. In the basement, I want to build a Swedish sauna. And I had thought of like having you pour those types of walls for the, like in the corner of the basement, so 2 additional walls for the sauna. But I'm not so sure when the walls, those walls are covered with, say, cedar paneling, if that heat is going to ruin the foam. Because that sauna is going to get 180 to 200 degrees.
That's not enough to damage it.
So that would
Yeah.
be fine. Because that would make a very efficient sauna.
Yeah, it certainly would.
Yeah.
What's it like to live in an ICF home? These are some of the comments that I've heard from people. Doesn't get very dusty. Yep, got a lot of kids and leave the doors open, it's going to get dusty. But aside from that, there's not that natural air leakage. And you wouldn't maybe realize how much that brings in a lot of dust. It pulls it in through all kinds of cracks and crevices in your walls. Another thing about it, most ICF homes, it does depend somewhat on the size, but on the smaller ones in particular, your doors are going to close funny because it's airtight. And so the door's not going to want to close quite as easily. You can't just give it a shove and it latch. You have to pull them closed. So that's slightly annoying. But you open a window and that doesn't happen. So that's how you know it's due to how tight the home is. Another one, wow, it's windy out there. You don't know how windy it is when you're inside a home because one, the sound, but two, your wood homes shake. It's almost imperceptible, but you do notice it subconsciously. An ICF home, you're always surprised when you open the door and find out how windy it is because you haven't felt and heard a thing. Absolutely, yep, you can still hear loud things. They'll particularly come through windows or the attic because those are pretty normal. Triple panes help with that somewhat. The extra insulation in the attic helps somewhat. But as far as wind goes and a lot of the normal sounds, very, very quiet. Yeah?
What are you recommending in terms of quality of windows and doors in conjunction with ICF?
Windows are a budget calculation. Whenever possible, I'd like our U values to be 0.2, below 0.2. There are some great windows out there we can get down to 0.14, maybe even less, but those are probably coming from Europe. We can get some pretty good Canadian windows that will be about 0.16, 0.17. And then there's domestics that will be very close to 0.2, say maybe 0.22, 0.21. So that does depend on what your budget is.
So a good place to invest.
Good place to invest is the question. That's harder to say. Windows are more of a comfort thing than they are an efficiency thing. The difference between an Energy Star window and the best triple pane you can buy is going to be less than $50 a year, even on a pretty good size home. It's more about, do I want to feel a chill if I have a big bank of windows? Buy it. Triple panes, you're not going to feel that chill.
Do you prefer fiberglass over vinyl for these houses, or wood?
Do I prefer fiberglass over vinyl or wood? My preference is fiberglass because it has the same expansion characteristics as the glass, so the seals in theory will last very long because they aren't moving at dissimilar rates. Vinyl, yeah, we can still use vinyl. There is a newer kind of vinyl called UPVC, which is unchlorinated. That's more dimensionally stable. I like using that as well. Wood is actually not my first choice. Yeah, it's beautiful, but it's not my first choice. What other things? What's it like to live in a home? And that's the no new home smell. So in my own home, even 3 years after we built it, we'd go away on vacation and I'll turn off the ventilator because no sense running it when nobody's there. They don't need fresh air. I come home, new home smell. But when it's running, you never have that. Well, what's a new home smell? But it's off-gassing of your materials. The adhesives, the countertops, all kinds of things off-gas. So that just lets you know that we're bringing in the right amount of fresh air. We're getting rid of harmful chemicals. Big advantage. John?
Do you have an opinion of Anderson 400 for windows?
They're a good, I'd call them a good entry-level wood window. Yeah. I can, for the same cost, get you a much higher performing window. Yeah. At this point, it's question and answer. So anybody have any questions about anything we've covered? Or haven't covered, for that matter. Yeah.
The place we're looking to build, I'd like it to be off-grid. So the type of heating you're talking about, does that require a lot of energy if I wanted to do solar and or wind?
Would off-grid include using any sort of gas, propane, natural gas?
Yes.
Okay. If you were to use natural gas, it's going to be a lot easier. My preference for net zero homes is all electric, so a heat pump, because then I can use solar panels to replace all my energy usage. Solar panel can't ever pay my gas bill, right? Or get rid of my gas usage, is maybe how I would say that. A heat pump, yeah, it uses more electricity than a furnace, but it uses no gas. So those are things where we would do energy modeling and look at costs of various systems and figure out what's best for your situation. Yes?
You showed us about running electrical conduits and things like that. What about plumbing?
I didn't even cover plumbing because plumbing doesn't go in exterior walls. You only ever go through the wall for, say, a spigot, but we don't run any plumbing in an exterior wall anyways, so it's a non-issue.
Okay.
And that's just because in most homes it would freeze, so our code doesn't allow it. Steve?
You were talking about solar, and we talked about solar once before a little bit. There's difference in the roofing or structural?
Only that when we order the trusses, we'll tell them design them to carry a little bit more weight to accommodate the panels. That's the only difference. Most of the time there's, if you're looking at retrofitting and it's a newer home, we can actually look up the calculations on that roof and see if it's got enough strength. But otherwise, hire an engineer. He'll tell you how to beef it up to receive the solar panels. Yep. Yes?
When you pour the concrete floor for the whole house, do you put some type of gravel, pea gravel, whatever, and or foam underneath the concrete floor?
So the question is, do we put pea gravel and or foam under the concrete slab of a home? Always foam. We always want to insulate it. We don't want any spot in the home uninsulated. So yes, it always has that. Pea gravel, that's going to depend on what your soil type is. If you're in a nice well-draining sand, you don't need it. Right? If I can take a 5-gallon bucket of water, dump it out, and it's gone in a minute, you don't need pea gravel. Any other questions? Yeah.
What kind of R value do you want in an attic if you're already at a 23 in the wall?
Good question. What kind of R value in an attic? That depends on a couple of factors. One of them being, do I have a cathedral ceiling or a flat ceiling? Another being what type of insulation I'm using. Is it a vented attic or a non-vented attic? The simplest answer I can give you is in a vented attic with a flat ceiling, we want to be at least R60. And that's with cellulose. If we're using a solid insulation that doesn't have convective looping, we could be closer to 30 and actually be just as efficient. But the reason we have to go to 60 in a loose fill insulation is to accommodate that convective looping. Anyone else? Okay, well, thank you all for attending. I'll be here for a bit if you want to have one-on-one questions afterwards, but I appreciate you coming very much. Thank you.